Okay, so on page 136, I'm going to start by looking at number 4. Again, this was one of your homework problems from last night. So we were solving this using that substitution method. Number 4, as it's set up right now, does not have an equation with a variable already by itself. That means I'm going to have to move some stuff around. Which of these equations, the top or the bottom, do you think would be easier to get a variable by itself? What'd you say? The bottom, and what would you get by itself? You could get x by itself. I would probably choose to get y by itself because that just means I have to move the x term to the other side and then I'm done. If I want to get x by itself, then I have to move the y and then divide by 4. So 2 steps versus 1. You can do either. You could also get a variable by itself from that top equation. That's fine. My suggestion, just like yesterday, was to pick the easiest option. What's going to be the least amount of work for you? And that would probably be to get y by itself in the bottom equation. So I'm going to go ahead and do that here. And that would give me y equals 11 minus 4x. On your paper, if you wrote this as y equals negative 4x plus 11, that's the same thing, okay? And that's fine. So now that I have y by itself in the second equation, I'm going to go ahead and take this stuff and plug it in for y in that top equation. So that would be 8x plus 2 times 11 minus 4x equals 13. Now I'm going to distribute the 2. So I have 8x plus 22 minus 8x equals 13. Now I'm going to combine my like terms, and I have 8x minus 8x. That's just 0. So my 8x's are gone. I have no more x's, and I'm left with 22 equals 13. I want you guys to notice that I have no more variables, and I have a statement that's not true. 22 is not equal to 13. So what do you think that means for my solutions here? I have no x's and no y's to solve for, and I've got something that's not true. Yeah, this means that I've got no solutions. On our graphs, no solutions look like parallel lines because they didn't have an intersection point, there was no solution. Algebraically, if I get an equation with no more variables that's not true, that's going to give me no solution. We may also see problems that we solve algebraically that we end up with 0 equals 0. No more variables, but I get an equation that is true. That would be an example of infinitely many solutions. Remember on a graph, that was when I had a line and then the same line right on top of it for infinitely many solutions. Algebraically, it would look something like 0 equals 0. Something where I've got no more variables, but it is true. Questions on number 4? Or any of your other homework problems while we're here? Okay. So today we're going to look at one more algebraic method for solving a system of equations. So far, the strategies that we've looked at have been graphing, substitution, and then today we're going to look at a strategy called elimination. So on page 138, we're going to talk about this elimination method for solving systems of equations. The big idea behind elimination is similar to the big idea behind substitution. So for substitution, the goal was to take an equation and instead of having 2 variables, rewrite it so that we only had 1. Elimination has the same goal. We want to get our equation down to just 1 variable, but we go about it a little bit different way. So what we want to do for elimination, as we talk about the setup here, which we'll look at in just a second, you want one variable, could be the x's or the y's, doesn't matter. You want one variable to have opposite coefficients. So for example, 2 and -2, opposite coefficients. -14 and +14. So I want one of my variables, either the x's or the y's, to have opposite coefficients. I want one of my variables to have opposite coefficients so that I can add my equations together. And when I combine like terms, those coefficients that have those variables that have opposite coefficients will eliminate out of my equation. Similar to what we saw with our homework problem just a minute ago. We had positive 8x and negative 8x. So when we combine our like terms, we didn't have any more x's. That's the idea behind elimination. So if we take a look at example 1, this is a problem that is set up really nicely for solving with elimination. Okay, this one's nice for solving with elimination because if we look, our y's already have opposite coefficients. The coefficients on my x's are 1, both positive, but on y's, we've got +1 and -1. So I have opposite coefficients here for my y's. That's what I want. So what I'm going to do now is add my equations together by combining like terms. So x plus x, or 1x plus 1x, would give me 2x. +1y minus 1y means I've got no more y's, right? Y's are gone. Equals 3 minus 9, that's -6. So I have eliminated the y's from this equation. That's why it's called elimination. Now what I'm left with is an equation with only one variable that just is going to take me one step to solve. So I'm going to go ahead and divide both sides by 2 to get x by itself. And we find x to be -3. And now this is just like yesterday. We have a value for one of our variables. So I'm going to plug it back into one of my original equations to solve for the other. If I have x, I can now find y. So I'm going to go ahead and plug this into my top equation. If you want to plug it into the bottom one instead, that's fine. But this would be -3 plus y equals 3. And now to get y by itself, I need to add 3 to both sides. So I get y to be 6. And then just like we've done for everything so far, solving our systems, we're going to give our answer as an ordered pair. So -3, 6. Questions for me so far? Okay. So this example I said was set up really nicely for elimination. That's not always going to be the case. Just like yesterday when we worked on substitution, we had several examples where we had to get a variable by itself, right? Like that homework problem that we looked at, we had to get y by itself in that second equation. We had to do some rearranging. So if we take a look at example 2, same idea. We're going to have to do a little rearranging here. We're going to have to do a little manipulating. If I take a look at my system here, I've got 6x and -4x, and then we've got -7y and -7y. So I don't have opposite coefficients for either of these variables, but the y's are pretty close, right? They at least have the same number. They're not opposite signs, but they're pretty close. So if I don't have coefficients that are opposite for either of my variables, what I can do is multiply one or both equations by something to get a variable to have opposite coefficients. So what I would want would be a -7y and a +7y. To get from -7 to +7, I could multiply by -1. So that means I want to multiply one of my equations by -1. Does anybody have a preference? Top or bottom? Okay. Let's multiply the top equation. No particular reason. I'm going to multiply the top equation by -1, and then I'm going to rewrite it down here. So that means I'm multiplying every term by -1. Since I'm doing the same thing to every term, this is okay to do. So I would have -6x plus 7y equals 4. Now I've got opposite coefficients, which is what I wanted. And I'm going to add my equations together. -4x minus 6x would be -10x. -7y plus 7y means my y's are gone. And that equals 26 plus 4 is 30. Now I want to get x by itself, so I'm going to divide both sides by -10. And I get x to be -3. I have a value for x, so I can plug that into either of my original equations and solve for y. I'm going to choose to plug this into my original top equation. No particular reason. Bless you. If you want to plug it into the bottom one, that's fine too. So this would be 6 times -3 minus 7y equals -4. 6 times -3 is -18. Minus 7y equals -4. I want the y term by itself, so I'm going to add 18 to both sides to move it. Now I've got -7y equals 14. And I'm going to divide both sides by -7 to get y by itself. So y equals -2. I found x, I found y. The only other thing I need to do is actually write my ordered pair for my solution. So -3, -2. Now, in second hour, we actually multiplied the second equation by -1 instead of the top one, okay? We got the same answer. In fourth hour, we plugged our solution for x into the bottom equation instead of the top. We got the same value for y. So as you're working through these problems, you may not approach them exactly the same way as your neighbor. That's okay. As long as you are both careful with your work, you're going to end up with the same solution. Questions for me so far? Okay, let's hop on down to example 3. So example 3, again, isn't, I see a couple people still writing, so I'll hold on a second. Okay, example 3 isn't set up right now for me to jump straight to adding those equations together, right? I don't have the same coefficients. I've got 2 and 1, 5 and 2. But just like the other day when we were working on substitution, I said pick the option that's easiest. There is, in my opinion, an easier variable to be able to eliminate here. I'm going to have to multiply one of these equations by something. What variable should I eliminate and what should I multiply by? So we've got 2 and 1. We've got 5 and 2. What are we going to end up eliminating? Yeah, if I multiply that bottom equation by -2, my x's will have opposite coefficients. So let's go ahead and do that. So this would give me -2x plus 2y equals 0. Oops, sorry, I did that wrong. Every term, so -4y equals 0. And then I'm just going to recopy that first equation over here to make it a little easier to add them together, just so they're lined up. So that would be 2x plus 5y equals negative 1. I didn't change anything about that top equation, and I've multiplied every term in the bottom equation by negative 2. Now that my x's have opposite coefficients, I'm going to go ahead and add these equations together. 2x minus 2x is nothing. I've got no more x's. 5y minus 4y would be 1y. And that equals negative 1 plus 0 is negative 1. So I have 1y equals negative 1. Or if I'd rather, I can write that as y equals negative 1. So I have a value for y. Now I'm going to plug that in to one of my original equations and solve for x. I'm going to choose to plug it into the bottom equation. That seems a little easier to me. If you'd rather plug it into the top, that's fine too. So I have x plus 2 times negative 1 equals 0. So this is x minus 2 equals 0. Add 2 to both sides to get x by itself, and we get x to be 2. So my solution as an ordered pair is 2 comma negative 1. If we had chosen to eliminate the y's instead, that's fine, but it means that we would have had to multiply both equations by something. Okay? There's no nice number that I can multiply 2 by to get to 5. And there's no nice number I can multiply 5 by and end up with 2. I would have to multiply both equations and look at getting their least common multiple. Okay, so that's why eliminating the x's was probably the easier choice for this problem. If we take a look at example 4, though, it's kind of a toss-up here. My coefficients for x are 4 and 3. So if I want to eliminate the x's, I'm going to have to multiply both equations by something. My coefficients for y are negative 7 and 2. So again, if I want to eliminate that variable, I'm going to have to multiply both equations by something. So this is a toss-up. Does anybody have a preference on what they would like to eliminate? Is anybody looking at these and thinking, well, the y's at least have different signs. Let's eliminate the y's. Couple nods. Is anybody looking at the x's and saying, well, those are smaller numbers? Maybe I'd rather do that. That's okay. This is a personal preference at this point. It's a toss-up. You're going to have to multiply both equations by something. So I did see a couple more hands for I'd rather eliminate the x's. So we'll go ahead and do that. I will tell you that in 4th hour, we chose to eliminate the y's because of those opposite signs. We're going to end up with the same solution that my 4th hour class got. Okay? As long as you're careful with your work, you're going to end up with the same solution. So if I want to eliminate the x's, I need the least common multiple between 4 and 3. What's the smallest number that I could divide each of those by? Or let me rephrase that. What's the smallest number that is divisible by both 4 and 3? 12. Yeah. So 4 times what would give me 12? 3. And 3 times what would give me 12? 4. If I had chosen the y's, it would be 14 would be my least common multiple. So I'd have to multiply the top equation by 2 and the bottom equation by 7. Now there's one more thing for these x's. This would give me 12x and this would give me 12x, but I want them to have opposite signs. So I have to make one of these negative. Do you want to multiply the top one by negative 3 or the bottom one by negative 4? Okay, top one by negative 3 it is. And now I'm going to recopy our equations off to the right. Negative 3 times 4x would give me negative 12x plus 21y minus 30, or equals, I should say, negative 30. For our bottom equation, 4 times 3x would be 12x plus 8y equals negative 28. Now our x's have opposite coefficients, so we can go ahead and add these equations together. So when I add them together, my x's are gone because negative 12x and positive 12x is 0. 21y plus 8y is 29y. And on the other side of my equal sign, negative 30 minus 28 is negative 58. Now to get y by itself, I'm going to divide both sides by 29. And we get y to be negative 2. Now that we have a value for y, just like every other problem that we've done, we can go ahead and plug that into either of our original equations and solve for x. I'm going to choose to plug this into the second equation. That seems a little easier to me. If you would rather plug it into the top equation, that's fine too. So I'm going to get 3x plus 2 times negative 2 equals negative 7. So 3x minus 4 equals negative 7. I'm going to add 4 to both sides. And I get 3x equals negative 3. Now divide both sides by 3 to get x by itself. And I get x equals negative 1. So my solution as an ordered pair would be negative 1, comma, negative 2. Questions for me on example 4? Okay. So in some of my earlier classes today, we chose to eliminate the y's. Instead, we got the same solution. We chose to plug in, if you look up the notes, he actually chose to plug in my y value to the top equation instead of the bottom equation. I got the same value. So just be careful with your work and keep in mind that your specific steps through a problem, even if you and your neighbor are both using elimination, your specific steps may be different than theirs. As long as you're careful with your work, you're going to get the same answer. Okay? So for tonight, for homework, or really the last 20 minutes or so of our class for homework, I want you to work on page 139, officially 1 through 4, but if you get the bottom ones done too, 5 and 6, that's fine as well, okay? So officially 1 through 4, but if you go through 5 and 6, that's okay. And then you have a Delta Math assignment that will have you practice our algebraic solving strategies, okay? So that's what we're gonna work on.